Light is amazing. It lets us see the world around us. From the sun's rays to a lamp's glow, light is essential. But did you know light travels differently through different things? Think about it. We see through air easily. Looking through water changes how things look, and glass can bend light in fascinating ways. Let's explore how light, this essential part of our universe, behaves. Light is a form of energy called electromagnetic radiation. It travels incredibly fast, especially in a vacuum where there's nothing to slow it down. In a vacuum, light zips along at a mind-boggling 299,792 kilometers per second. That's like circling the Earth over 7 times in just 1 second. This speed changes when light encounters different materials like air, water, or glass. These materials are called mediums. The way light interacts with these mediums determines how we see and experience the world. Air is all around us. We breathe it, see through it, and light travels through it effortlessly. Light doesn't slow down much in air. This is why we can see things clearly in the air. When light passes from the air into our eyes, it allows us to perceive the world around us. Think about looking at a tree. The light bounces off the tree, travels through the air, and reaches our eyes. Our eyes and brain work together to process that light and tell us we're looking at a tree. Section 4. Light's Underwater Adventure. Join us as we dive deep into the fascinating world beneath the waves. Water is a different story. Unlike air, it has unique properties that affect how light behaves. Light slows down in water compared to air. This is due to the denser medium that water provides. It travels at about 225,000 kilometers per second in water. This is significantly slower than its speed in air, which is about 300,000 kilometers per second. This change in speed causes light to bend as it enters the water. This bending effect is a fundamental principle of optics. This bending is called refraction. Refraction occurs whenever light passes from one medium to another at an angle. Refraction is why things look different underwater. Objects appear distorted or shifted from their actual positions. Have you ever tried to grab something in a pool and missed? It's a common experience due to the bending of light. That's refraction playing tricks on your eyes. The light rays are bending, making the object appear where it isn't. The object appears to be in a different position than it actually is, because the light reflecting off the object bends as it travels from the water to the air and then to your eyes. This bending alters the perceived location. Try this. Put a straw in a glass of water. It's a simple yet effective way to observe refraction firsthand. Notice how the straw looks broken at the waterline? That's refraction. The light bends at the water's surface, creating the illusion of a broken straw. Section 5. Through a glass, clearly light in glass. In this section, we will explore the intriguing relationship between light and glass, and how this interaction has revolutionized various fields. Glass is another material that interacts with light in fascinating ways. When light encounters glass, it undergoes a process called refraction, where the light changes direction as it passes through the material. Light travels even slower in glass than in water, about 200,000 kilometers per second. This reduction in speed is due to the denser atomic structure of glass compared to air or water. This slowing down and bending of light is what allows us to make lenses for glasses, cameras, and telescopes. These lenses can focus light precisely, enabling us to see distant stars or read the fine print in a book. One of the coolest things about light and glass is total internal reflection. This phenomenon occurs when light hits the boundary of the glass at a certain angle and is completely reflected back inside. This is how fiber optic cables work. These cables are made of thin strands of glass or plastic that use total internal reflection to transmit light signals over long distances. Light enters one end of the cable and bounces back and forth off the inside of the glass fibers. This allows data to be transmitted quickly and efficiently, making high-speed internet and telecommunications possible. This bouncing continues all the way to the other end, even if the cable is curved. The flexibility of these cables makes them ideal for a wide range of applications, from medical instruments to underwater communication. And who can forget prisms? These simple yet powerful tools have fascinated scientists and artists alike for centuries. A prism is a triangular piece of glass that can split white light into its different colors, creating a beautiful rainbow effect. This dispersion of light occurs because each color bends at a slightly different angle. This happens because different colors of light bend at slightly different angles as they pass through the prism. This property of prisms has been used in everything from scientific experiments to creating stunning visual effects in art and design. Section 6. Light in action, real-world wonders. The way light behaves in different mediums has led to incredible technological advancements. By understanding how light travels and interacts with various materials, scientists and engineers have been able to create groundbreaking technologies that shape our modern world. We've already talked about fiber optics, which are used to transmit information at high speeds over long distances. These thin strands of glass or plastic carry data as light pulses, enabling rapid communication across the globe. They're essential for the internet, phone calls, and cable TV. Without fiber optics, our ability to connect with others and access information would be significantly limited. Cameras use lenses to focus light onto a sensor, which creates an image. This technology allows us to capture moments in time, preserving memories and sharing experiences through photographs and videos. Eyeglasses use lenses to correct vision problems by bending light in a way that helps us see more clearly. This simple yet effective application of light principles has improved the quality of life for millions of people around the world. Telescopes use lenses and mirrors to gather light from distant objects, allowing us to see things far beyond our planet. This has expanded our understanding of the universe, revealing the wonders of space and the secrets of distant stars and galaxies. From the mundane to the extraordinary, light's journey through different mediums impacts our lives in countless ways. Whether it's the natural light that brightens our days or the artificial light that enhances our nights, its influence is ever present. It's a fundamental principle of physics that has revolutionized fields like medicine, telecommunications, and entertainment. From MRI scans that help diagnose illnesses to the fiber optic networks that keep us connected, light continues to be a driving force in technological innovation. Section 7. Light up your world. So the next time you see light shimmering on water, shining through a window, or creating a rainbow in the sky, take a moment to appreciate the science behind it. Light's journey through different mediums is a fascinating and essential part of our universe. By understanding these concepts, we can not only appreciate the beauty of light, but also harness its power to improve our lives. Keep exploring, keep questioning, and keep your eyes open to the wonders of light.